Now we're going to use LeakSeeker to find something that's nearly impossible to find. What we have now is our 47 ohm short, as we've seen earlier, but along this short path, because it's a power supply, we're going to pretend, there's also a large capacitor, about 1,000 microfarad capacitor. Now, that could muddy up your readings, and I'll show you why. If we start as a normal test, black lead to ground, 2-wire test, start for a new test. Now, if we go anywhere along this land, here's what's going to happen. We're getting all kinds of weird readings, and the reason for that is that every time we put the test lead on, this capacitor is trying to charge up, and we're getting that. So it's going to be, wherever you go, it's going to be near impossible because it's not a steady tone. So that's where the 3-wire test comes in. Right now, LeakSeeker in the 2-wire test is using black for ground as a reference, and on the red probe, it's using a combination of two things. It's putting out a calibrated amount of current and voltage through the probe, and also measuring the change in current and voltage throughout the probe, which means every time we touch the probe here, the probe is going to try to charge up this capacitor. So now what we're going to do is with the 3-wire test, we're going to flip the switch up to the 3-wire test. What that does is break up the probe putting out the special voltage and current signal as well as receiving. Now the probe is just a receiving instrument, and we're going to take this probe, which is just a regular piece of wire, alligator clip, and I put a piece of wire on the end just so I can solder it and circuit for myself. What this wire does is that this one puts out the calibrated current and voltage. This wire does the measuring. So the beauty of this is that we can go ahead and just solder this somewhere in the circuit where we know there's a short. And I'm going to put it over here, because we know that's along the shorted trace, as you can see. That's the trace that's marked with the red, which we knew from measuring earlier was at a 47 ohm short. Now what's happening is that the calibrated current and voltage is coming along here, and this capacitor at this point is charged to a point. Now it's happy, everybody's calibrating, all of the temperatures are all calibrating, so that now we can start getting a stable reading. So now I'm going to push for a new test, as usual, and now I'm going to start probing along. So again, it doesn't matter where I start, but I'm going to start here. Okay, so I got a nice steady tone now, and notice it's going to stay each time, and it's not going to be that charging thing. I come here, it's lower. In fact, there's no tone because we know the short's not in that direction. It's this way. So let's go closer. Okay, next pad along is this guy. Okay, we're getting closer. Next pad along is this guy. Okay, it just recalibrated. Good sign, we're going in the right direction. Let's go a little further. Oh, well, what's happening here, interesting, is that no matter where we go, we get the same tone. And the reason for that is that there's no current flow in this trace. That trace is not where the short's on. The short is clearly where the tones are changing. So let's keep on going back. Okay, so right here, that's where the traces, or that's where the tones are the same. Now the trick to remember, the 3-wire test is a little harder because it's not the one point that's going to be the highest, but it's going to be the very first point where it stops changing. So we know there's no short here, there's a short here, because that's the next step up, and keep on going, there's no change. The short's going to be right here, and of course we already know where it is because we looked at this earlier. That's where the 47 ohm short is. So that's using the LeakSeeker in the 3-wire mode, where again it separates the special voltage and current signal coming out through the 3rd probe and the sensing probe.